Hi class, and welcome to hopefully roughly the end of the week if you are watching this according to the schedule of when I scheduled to be learning about interquartile range. So we are continuing talking about data distributions throughout this lesson today. So what is interquartile range? Well, range, you guys might know this word from even 6th grade. This one might have stuck in your head more. Range is really just, it's the difference. So you subtract the biggest number minus the smaller number. So let's say in our classroom, you're all 12, 13, and 14, and then I'm 25. So the oldest person, me, is 25. The youngest person is 12. 25 minus 12 is 13. So the ages in our class range 13 years. They have a 13-year spread. They vary, they differ by 13 years from youngest to oldest. So, interquartile range. I had to grab my pens. Interquartile range. Well, range we just talked about. Interquartile. Inter means like inside. Quartile means quarters, breaking into fourths. So, interquartile range to me, inside. Quartiles, you break it into quarters. Quarters are 25 cents. How many quarters does it take to make $1? 25, 50, 75, $1. It takes 4 quarters. So it's the inside quarters or fourths. There's 4 quarters. Fourths. So quartile, I think of breaking it into 4 groups, fourths, quarters. And then you find the range. So biggest minus smallest. Now, sometimes we write the formal definition, explain it, and then do practice problems. Sometimes we do it a little bit backwards, where we start with a practice problem and you kind of learn through discovering it with the practice problem. So first, I gave us a data set. Okay, a data set that's just a list of numbers. It can be describing some part of data. This could be, I don't know how many pounds of milk each person bought for the week, how many gallons of milk, how many, it could be whatever, ages of children in daycare. So I gave you a data set. The first step, guys, whenever you get a list of numbers, what do you need to do with them? Immediately when you get a list of numbers, you need to put them in order. Put them in order from smallest to biggest, from least to greatest. So 0, because we don't have any negative numbers. So 0 is the smallest. Cross it out, write it down. Okay, then we have 1.5. All right, do we have any 2? 2.5. Any 3s? We have 1, 3. Any 4s? We have 1, 2, 3 4s. 1, 2, 3. 5, 6s, 7. And 7.5. So you guys should be actively taking notes while I'm taking them. Writing this down in your notebook. Pausing as you need. So we had our data set. We put it in order. Okay? Smallest to biggest. So right off the bat, you guys can see mode, that word we revisited last year from 6th grade, mode. Which number is the mode? Most often. Occurs most often. Mode, most often, or seen most. Well, 4 is repeated 3 times, whereas no other number is repeated. So 4 is our mode. That was just a little side task. Let's go back to what we're learning about, though. So, we said interquartile range. So they didn't ask us just for the range. If they said find the range, we would just do biggest minus smallest. We do 7.5 minus 0. Well, 7.5 minus 0, you're minusing nothing. So it's 7.5. So the range is 7.5. But it doesn't say find the range. It says interquartile range. Interquartile, quartile, quarters, fourths. we need to break this list of numbers into fourths, into 4 equal sections. So we already learned how to break it in half. How do we break a data set in half and put a line down the middle? What word means middle in math for statistics? Middle. Center. Hopefully what came to your mind, or you said out loud even, was median. So first we need to find the median, the middle. So 1, 2, okay, 3, nope. See, that's why I like crossing them out. I'm going to cross them out. So 1, 1. I'm crossing it out in yellow, so maybe you can't see it. But 1, 1, 2, 2, 3, 3, 4, 4. Okay, so because we have an odd set of number, we have an odd amount of numbers, we had a clear median. We had a clear middle number. I'm crossing it out in a light color so that I can still see the data set because we're not done with them. So I crossed out 4 on each side for different values, and that leaves us with the median of 4. So 4 is our median. Median. Okay, median. It's our middle. Okay, just think about it. What is half of $1? 50 cents. Half of $1 is 50 cents. So 2 quarters is 50 cents. 2 quarters. So this is quartile, quarters, quartile 2. Quartile 2 is another name for median. So we need to find all the inner quartiles. We need to do the 4 quarters, break it into fourths. So right now we broke it in half. All right. Now we need to basically find the median of the medians. Find the half of the halves. All right. So looking to the left of 4, all the numbers less than 4, we have 4 numbers. So from the outside to the inside, we have 0 crosses out with 3 because we're trying to find the middle of the lower half. But it leaves us with 1.5 and 2.5. So what's perfectly exactly in between 1.5 and 2.5? You might know it, you might not. Okay, if you don't know it, then you need to add the numbers together and divide by 2. So if you have your calculator, you type them in with the calculator. I've been doing this on my phone since a lot of you guys have contacted me calculating things on your phone because you don't have a calculator. So I'm going to show you how to do it on your phone since we have fractions. So fractions on your phone, guys. Just remember, fractions are the same as decimals. You need to turn it into it. So 1/2 as a fraction, drop the top, put it in the box. You do the top divided by the bottom. 1 divided by 2 is 0.5. So that means that 1.5 is exactly the same as 1.5, and 2.5 is the same as 2.5. So to find the middle of 1.5 and 2.5, first we add them. We do 1.5 plus 2.5. Okay, let's do that. 1.5 plus 2.5 and get 4. And then we divide by 2 because we added 2 numbers, divide by 2. 4 divided by 2 is 2. So 2 is perfectly between 1.5 and 2.5. So that means that 2 is the first quarter. 1/4, 1/4 into our data set is 2. So 2 is the first quarter. It's quartile 1. Okay. We know that 4 is quartile 2, or the median. So now we need to find the third quartile, the upper quartile. Okay, so we start from the median's in the middle, so we don't touch the median. So we have 4 numbers above or to the right of the median. So we count in and cross them out. Well, we don't have a perfect middle again. So we need to see what's perfectly between 4 and 7. You might know it, you might not. If you don't, you add the two numbers up right next to what's in the middle. So 4 plus 7. 4 plus 7 is 11. And then you do 11 divided by 2. So 11 divided by 2, 5.5. So that means 5.5 is directly between 4 and 7. That's the third quarter in, so that is quartile 3. So we found our first quartile, we found our second quartile, our median, we found our third quartile. And what we see is there's two numbers on this side of the first quartile. There's two numbers between the first and the second quartile, two numbers between the second and the third quartile, and two numbers between the third and the end, the last one. So we know that we perfectly broke it up into 4 equal sections. All right, now interquartile range, so calculating the IQR. Interquartile range, it's just the difference between the third and the first quartile. What does that mean? It's the difference. Difference is subtract between the third and the first quartile. So to calculate the interquartile range, you do the third quartile, quarter 3, and you subtract quartile 1. So let's do that. Let's put it into practice. Quartile 3 was 5.5. And then we subtract quartile 1. Quartile 1 was 2. So 5.5 minus 2. 5.5 minus 2, 3.5. So 3.5 is the interquartile range. Interquartile range, the IQR. So that tells us that between quarter 1 and quarter 3, the interquartile range, it ranges 3.5 digits. Now, it's important to know that the interquartile range has half of the data. We had 1, 2, 3, 4, 5, 6, 7, 8, 9. We had 9 points. Okay, well 4.5 is technically half of 9. We have 1, 2, 3, 4, 5 points between Q1 and Q3. Half of the data, more or less, lies between quartile 1 and quartile 3. All right, let's go on to example 2. Example 2. We're going to have another list of data points. We have 8, 5, 3, 6, 2.6, 6, 5. And let me give you one more, 8.2. All right. So, first order, what was the first thing that we did last time? First step, we put them in order from smallest to greatest. So smallest is 2.6, because that's less than 3, but more than 2. Then we have 3. Cross it out each time you write it, guys, so you don't repeat numbers or miss numbers. We have 5. We have 5 again. A 6. A 6. An 8. And then 8.2. So put them in order, least to greatest, smallest to biggest. Okay? Next, we find the median. Break it in half. So, step 1. Order numbers smallest to biggest, or least to greatest. Okay? Step 2. What was the second step that we did? We found the median. So from the outside in. Oh man, I meant to give you guys, hold on, I'm going to fix this right now. All right, to your data set, I must have missed a number. To your data set, add the number, just add the number 9. So then add the number 9 down here, and let's refine the median. I must have miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I miscounted and thought I gave you guys one more than I did, which changes the answer. Okay, so first put them in order. We did. Second, find the median. So I'm going to use a different color now that I messed that up. Cross out 2.6. When I cross out 9, cross out 3, and I cross out 8.2. Cross out 5, and I cross out 8. Cross out 5, and I cross out 6. All right, so in the middle, we actually have a median this time. The median is in the middle. The median is 6. So the median is 6, or quartile 2 is 6. So step 2, after we order them, guys, find the median. So first you put them in order, then you find the median. You find the middle. Because why are we finding the middle first? Interquartile, quartile quarters. We have to break it into fourths. We need to break it into 4 equal parts. Well, the easiest way to do that is first you break it in half, which we just did at the median, and then you basically find the middle number of both halves. You're finding the median of the medians. So step 3 is basically find the middle number of both halves. So on the left side, we have 2.6 crossed out when we cross out 5, and then we have 3 and 5. That leaves us with nothing. So we're in the middle of 3 and 5. What number comes perfectly between 3 and 5? 4. Good. If you didn't know it was 4, you could do 3 plus 5 is 8 divided by 2. 8 divided by 2 is 4. So 4 is quartile 1. It's the first quarter in. Okay? So now we need to find the third quarter, the third quartile. So we cross out 6 when we cross out 9. We cross out 8 when we cross out 8.2. So what comes directly between 8 and 8.2? You might know it, you might not. If you don't know it, you add up. You do 8 plus 8.2. 8. Let me turn this down so you can see it more. 8 plus 8.2, and then divide by 2. And it should be 8.1. Okay, so 8.1 comes directly between 8 and 8.2. That's our third quartile. So that means we have 1/4 of the data here, 1 out of 4, a quarter of the data here, 1 out of 4, a quarter of the data here, and 1 out of 4, a quarter of the data here, which we do. So 25% a quarter, 25% a quarter, 25% a quarter, and 25% a quarter of the data. So let's write down what we did for step 3. Step 3, okay? It's basically break each half in half, or find the median of the median. Break the lower and upper half in half. So we did the lower half, we did the upper half, and then we broke it in half again. We found the median of the medians. So these are the steps for interquartile range. Okay, the last step. We found the interquartiles. We found the 4 inside quarters. We got to find the range of the quarters. So step 4, for interquartile range, you have to do Q3 minus Q1. So you have to do the third quartile, 8.1. So the interquartile range is going to be 8.1 Q3 minus Q1. 8.1 minus 4, if you don't know it, guys, use your calculator. 8.1 minus 4, 4.1. So that is our interquartile range. Half of the data falls into half of the data has a range of 4.1 basically. The range from quartile 1 to quartile 3 is 4.1. That shows you how spread out the data is. Okay, that's not a huge range. Think about it. Babies come out weighing, let's just say, 7 pounds. Okay, think about how heavy the heaviest man in the world is. Okay, let's just say 407 pounds. So that's a range of 400 pounds. 407 minus a baby at 7 pounds is 400. But we're not talking about the big range. We're talking about the interquartile range. Where does about half of our population lie? Well, half the population probably lies more between the 100, 200 pounds. Okay? So it breaks it into 4 quarters, and then we find the range, the difference of Q3 minus Q1. So this is how to do it when you have a data set, a number of data points given to you. Okay, with our last example, we're going to do it with a dot plot given to you. So example 3, and I want you to actually write this dot plot down. So we have 80, 81, 82, 83, 84, 85, 86. Okay, so this is our dot plot, and then we're going to have a dot at 81, a dot at 82, dot at 83, another dot at 83, dot at 84, dot at 84, and dot at 84. So 3 dots at 84, and then 2 dots at 85. And we're going to find the interquartile range for this dot plot. Okay, so we're going to follow the steps that we just wrote. All right, order the numbers from least to greatest. Well, we actually already have them in order. Now, dot plots are kind of hard to do, especially if you don't have it on paper. Because on paper, you can cross it out. If it's on the screen, it's hard. You have to kind of cover your fingers up over it. So it might be easier to first just write out the numbers from smallest to greatest. What do we have? Well, the numbers are 80. No, just kidding. We don't even have an 80. Our numbers are 81, 82, 83, 83 again. Why am I writing 83 twice? Because there's 2 dots at 83. 84, 84, 84 again, 85. Now I'm really mad because I ran out of room because I messed up, and 85 again. So it's really easy to see from the dot plot, the number with the most dots is 84. So first we put them in order. Step 2, find the median. Okay, so find the middle number. Cross out 85 when I cross out 81. Cross out 82 when I cross out 85. Cross out 83 when I cross out 84. Cross out 83 when I cross out 84. The median should be 84. Let me check that with the dot plots. I'm going to go from the outside to the inside because dot plots are basically the numbers in order. Cross it out, cross it out, cross it out, cross it out. It leaves me with this dot in the middle, which is indeed at 84. So our median is 84. Our median is 84. Okay, so we have median 84. That's quartile 2. That's our median at 84. Quartile 2. Okay. Now, we ordered them, found the median. Break the lower and upper half in half. So, you can do it one of two ways. You can do it on the actual dot plot, or you can do it with the list of numbers. If we do it on the dot plot, 81 and so first I'm going to do the lower half. So I'm looking to the numbers smaller than the 84. We have 4 dots. So 81 and 83 cancel out, and we're left with a dot at 82 and a dot at 83. So I know directly between 82 and 83 is 82.5. If I didn't know that, I could do 82 plus 83 divided by 2. I personally think it's easier to do it with the number list. So I'm going to look at the lower half, the half of data that's beneath the median, smaller than the median. So I cross out 81 when I cross out 83. Cross out 82 when I cross out 83. That indeed leaves me with the first quartile directly between 82 and 83. Well, 82 plus 83 divided by 2, 82.5 is directly in half. All right, now we need to break the upper half in half. So the upper half, cross out 84 when I cross out 85, cross out 84 when I cross out 85. So right between 84 and 85, I know that it's 84.5. If I didn't know that, do 84 plus 85 divided by 2. That's my third quarter in. We have first quarter in, second quarter in, the median, third quarter in. If we did it on the dot plot way, we'd say we want all values above, bigger than the median. So that leaves us with these 4 dots. This one crosses out when this one crosses out. This one crosses out when that one crosses out. So it leaves us directly between 84 and 85, which is 84.5. All right, the last step, quartile 3 minus quartile 1. So the interquartile range is going to be quartile 3 minus quartile 1. So 84.5 minus 82.5, which is 84.5 minus 82.5. 2. So the interquartile range is 2. That is not very spread out. So the interquartile range. Now you guys may remember Boxplots, okay? The last Khan Academy assignment you need to do this week is reading Boxplots after you watch the video. Okay, this is kind of a check-in for me before we move into next week. So, Boxplots. All right, box and whisker plots. You put one line at the very last spot where you had a data value. So our smallest number where we had a data value was 81. So we put right at 81 a data value. So we could recopy our number line. 80, 81, 82, 83, 84, 85, and 86. So I recopied the number line. I'm going to zoom in a little bit. I want to make sure you guys can see this, because we're focusing really right here. Okay, so I recopied the number line. Now we're going to make our box and whisker plot. So we put a line at where the smallest number is, and then you put a line at the biggest. So our biggest number was at 85, so we're going to put a line there. Okay, then we calculated quartile 1 at 82.5. Quartile 1, 82.5. That's directly between 82 and 83. So I'm going to put another line there, right between 82 and 83. Quartile 3 was at 84.5. 84.5, directly between 84 and 85. So I'm going to put our line there. And then our median, where was our median? Our middle number was at 84. Our median, our quartile 2, was at 84. So we put it right at 84. So a box and whisker plot has 5 lines. You make the box connects the quartiles of quartile 1 and quartile 3, because quartile 1 was 82.5, quartile 3 was 84.5. So the interquartile range, you just look right here and subtract right here, and then you make the whiskers. And that's your box and whisker plot. We're going to be focusing more on comparing box and whisker plots next week as we continue learning about statistics. So I hope after watching this lesson, you guys feel like you understand interquartile range a lot better. You understand how to break the inside of the data into inside, or into quarters. Break it into quarters. Then you pick the inside quarters, quartile 1 and quartile 3, and find the range. Subtract them. It's really easy when they give you a box plot, because when they give you a box plot, you know the median's right here. So you know Q3 is right here, 84.5. Q1 is 82.5. And then you just do 84.5 minus 82.5. 84.5 minus the 82.5, and that gives you 2 for the interquartile range.